Okay, so today we're just going to do an introduction to probability with some pretty basic probability questions. And I have a couple of scenarios here. We're going to talk about false positives and negatives as well. So I have this example up that talks about the shooter seeming hot, meaning like a basketball shooter, and them seeming hot, quote unquote. What that means in statistics is that they are having a long run of success in this case. So it says here, is there such a thing as a hot hand in basketball? Belief that runs must result from something other than just chance influences behavior. If a basketball player makes several consecutive shots, both the fans and her teammates believe that she has a hot hand and is more likely to make the next shot. Several studies have shown that runs of baskets, made or missed, are no more frequent in basketball than would be expected if the result of each shot was unrelated to the outcomes of the player's previous shots. If a player makes half of her shots in a long run, her made shots and missed behavior, just like the tosses of a coin, and that means that the runs of makes and misses are more common than our intuition expects. So this is this idea, there's in stats something called the law of large numbers and the law of small numbers. The law of large numbers means that in a large number of practices, there's going to be a predictable outcome as far as probability goes. Not for the next shot in this case, but there's a predicted number. Like if I were to toss a coin many times, a large number of times, right? If I were to toss a coin a large number of times, I would get very close to that probability of having 50% heads and 50% tails. That's the law of large numbers. The law of small numbers is not a thing. So people try to take that law of large numbers and apply it to a small subset of let's say, shots in this case, like she's taking shots at a basketball. And they try to apply it to a small number of shots, and that is not necessarily true. So I'm going to take my coin example. If I tossed a coin 10 times, before I even did it, I would expect to get about 5 of them being heads and 5 being tails. But let's say that I'm on my 7th shot and I've had all heads so far. Does that mean for sure that I'm going to get tails next time? We all know that the answer to that is no. So probability is chance outcome. So in the short run, anything can happen, but in a long run, probability is going to reach a very predictable result. Okay, here's another one that is kind of interesting, talking about the law of averages. Belief in this phony law of averages or small numbers, like I was just talking about, can lead to serious consequences. A few years ago, an advice columnist published a letter from a distraught mother of 8 girls. She and her husband had planned to limit their family to 4 children, but they really wanted to have at least 1 boy. When the first 4 children were all girls, they tried again and again and again. After 7 straight girls, even her doctor had assured her that the law of averages was in your favor, 100 to 1. Unfortunately for this couple, having a children is like a coin toss. 8 girls in a row is highly unlikely, but once 7 girls has been born, it's not any more likely that the next one will be a girl. You still have a 50% chance that that next child is going to be a girl. So it's that concept right there. Okay, I have one more example that kind of goes through that same thing. Understanding that the more you sample, the closer you're going to get to that probability, that true probability for whatever event you're talking about. So in the long run, we call that long run probability. You can use that, like tossing a coin, the long run probability of getting heads is going to be 50%. So that's long run. In the short run, anything can happen. That's the introduction for probability in that one. The other thing that you will encounter is this idea of false positives and false negatives. You do need to understand that those are a thing. I have COVID-19 data up right now, and it talks about a false positive and a false negative and what that would look like in context of our pandemic that we're currently in. So a false positive, if you were to get a false positive result with COVID, what that would mean is that you tested positive, but really you do not have the virus. A false positive means you got a positive COVID test, but you don't actually have COVID, okay? So you would fall under the people without COVID, okay? Because The people without COVID would be the true negatives, the people who got negative, or the people who got a false positive result. They don't have COVID because it was a false positive. On the flip side of that, we have what are called false negatives in the medical world. A false negative would look like this. It would mean that you got a negative COVID test, but really you have COVID. One of the things that I'm going to be asking you guys to do is to assess a certain situation in whether a false positive or a false negative would be more detrimental. In this one, a false negative would actually be more detrimental because you would go about your normal activities thinking that you got a negative result. You would think you did not have COVID, but really you do have COVID. So you would have the ability to spread it. So please understand that when I ask you what's worse, a false positive or false negative, that's not really open to interpretation. In that case, there's going to be one that is going to be more detrimental to other people. So in this case with COVID, it would be worse to get a false negative result. And those are what your problems look like. You're going to be talking about long run probabilities. In the long run, you have that expected probability. And then you also are going to be talking about false positives and negatives and which one has a worser consequence.